seeing Buddha screaming thug life. Get it, baby, you know I'm the plot right. Fucking got a feeling that it's gonna be a long night. Whoa, everything I touch turn cold. Need no introduction cause they know Brit and Mo, I hit the lotto, my motto. Roll up gelato and throttle a couple models staccato who fucking brought up the bottles. I'm gone ham, this ain't even luck, all planned. Y'all know who the fucks I am. Burning bucks, smoke bands. Always been the MO since the start of this. And now I'm on a mission like I'm Artemis. Hey, we gon' turn the crib into a club like Hennessy and Buddha screaming thug life. Get it, baby, you know I'm the plug right. Fucking got a feeling that it's gonna be a long night.
Never an average night, 2-4 hours up in the day, I gotta make it right. 18 of those, I'm in the cave, I gotta make some light, make it hype, even if we break a night. And even if things go left, we gotta make them right. Chillin' with mine, we triple up, they on the double up, triple dub. Came from the basement, we only going up, they loving us. Up in the booth, I'm getting dizzy, but they the cup is up. Toast to my people that's on the come up, and you live with us. Ain't all about the trigger bus. Looking at my watch, your spirit bomb, both hands is going up. You going coast to coast with us. See the flows is flowing, overflowing, yeah, the cup it runneth over, tidal wave up in the ocean.
We gon' turn the crib into a club like Hennessy and Buddha screaming thug life. Get it, baby, you know I'm the plug right. Fucking got a feeling that it's gonna be a long night.
open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me
I've been getting out of bed these past few days. Think it's fair to be proud about it. I've quit ordering from all those fast food chains. I'm feeling better, there's no doubt about it. And my days are brighter, my shoulders are so much lighter. Just for a moment there, I thought that there was nothing more to life. I thought about it, wrote a couple songs about it.
Good afternoon, everybody. How are we today? You think Kyle? We're gonna try and look up 2019 paper 1. If all you need it, let me know. I will send it to all you. 2019 paper 1. Good evening, Hasman. 2019 paper 1. If you need it, let me know. Actually, I'll just link it and pin it in the chat one time, right? I'm gonna make a folder for it here, yes. I'll put all the paper ones that I have in here, right? And I'll pin it in the chat. Right, so click the link. Oh shucks, I sent it from a wrong account. Yes, that is okay. I'll still pin it. Right, I need to change my account then. If you ain't subscribed, don't feel shame. Hit it. Nobody ever vex with you. Alright, let me make sure that's here. Yes, should be able to pin this here. Good. Alright, so tell me if I look at view it on that drive. Tell me. My volume real low. No. What about they? They should be a little better. Probably because my RTX voice on. Sounding better now? Well, at least we could get through all these kinks before we start now. Tell me if you got to go there with my voice. Still low for you? Is it low for everybody else? Hello Sangita, what you seen? You good now? Right, good. Once it good. That's the most important thing. Once it good, we good to go. Alright, tell my fellas seeing the video properly. Well, all I could follow in all I in the document all I have for it. Alright? Let me just alright. So we don't need that no more. Nice. Cool. So 2019 paper 1. Let me get this on the road. At any point in time, if all I have any questions, if all I want to do any topics, let me know. Tomorrow will be the last day we have any lives. Hopefully everybody get total in their multiple choice. Wednesday I'll be doing the solutions once I get the multiple choice. So in your exam, please take note of what you answered, like number 1, what you put for number 1, what you put for number 2, and so on, to double check at the end of when you're doing the solutions. So yeah, if all I have any topics all I want to go through, need to say it in the chat. When this video goes live on YouTube after the live is ended, leave a comment under the video if it is you want me to do a topic. We could do it Tuesday. Tuesday we could start with the stream a little earlier. Also, all you have to let me know what time everybody will be available on Tuesday. If it is I can start the stream about 12 o'clock on Tuesday, I'll start at 12 o'clock and we will do probably a 6-hour stream if need be. If not, we could just do a 2-3 hour stream and call a judge. Alright, so that out of the way. There we go. The expression x minus 2 is a factor of, I'm going to just pull up this calculator here in the meantime so you don't have to dig up for it. Right, the expression x minus 2 is a factor of, so all you have to do, if I have f of x divided by x minus 2, well, that is f of 2. If this is equal to 0, then x minus 2 is a factor. So I just have to check and see which one of these expressions here will give me 0 when I substitute x is equal to 2. If I recollect correctly, the answer for this is A, because this is a repeated question. 4 into 2 to the power 4 minus 2 into 2 squared minus 56, 0. So A is the answer here. When that is divided by x plus 2, the quotient is, so again, I have f of x divided by x plus 2 this time. This is equal to f of minus 2, which is minus 2 cubed minus 7 into minus 2 squared plus 2 into minus 2 minus 1. Jump on the calculator again. Well, this here we could work it out very, very easily. There's minus 8 minus 14. 2 to the 4, 7 4 are 28, sorry. Minus 2 minus 1. So now we'll get a minus, looking like minus 39. Minus 8 minus 28 minus 2 minus 1 minus 39. B. Given that so by so can be expressed in the form. Okay, so this is a completion of the square question. Jesus Christ. Alright. So we know that how a x squared plus bx plus c is equal to, Jesus Christ, a into x plus h squared plus k. I'm doing it like this because I think it could be a little easier for myself. If you realize in A, B, C, and D, all of these have the same first part. A into, we don't have to long divide their exodus. Long division is a method, but this is the shorter method to do it. Alright, so back to number 3. A, B, C, and D, it have the same first part. A into x plus b, oh no. Alright, so A is the only one that's different for the first part. X plus b over 2a. Now, if you look at it carefully, all of these are of the form a into x plus h squared plus k. Completion of the square. If I remember, a is a, h is b over 2a, and k is c squared minus 2ah, yeah, or c minus ah squared. Yeah, it's c minus a h squared. Yes, c minus ah squared. No, Gerald, if you long divide, you will get the quadratic and you will get the remainder. If you want me to do the long division, just say so, I'll do it. Right, so I know that based on my analysis here, B, C, or D is the answer. Now I need to figure out which one is c minus ah squared. So we have c minus ah squared with c minus a into b squared minus 4a squared. The a cancel with this a, so I get c minus b squared over 4a. I use my so. I get 4ac minus b squared over 4a. So the answer is C. Now this question, it is a little confusing. Right, it is a little confusing. Right, I will say it's a good question to test your skills. It's an extremely good question to test your skills for completion of the square. So, to me, they're the easiest way to do it. You just have to be very, very careful in your algebra. That's it. If this is the manner in which you want to do it, you can do it like this. You can compare coefficients if you want. You can also use the steps method. I only showed on stream the comparing coefficients method, and I also showed these formulas you can use. Alright? If need be, we can always run through this tomorrow. Today we're just focusing on the paper one. Which of the following graph best represents that? There's a negative x squared, which is a sad face, so it's either B or D. I'm checking which part it cut in the x-axis. So I have x into 1 minus x is equal to 0. That is where it will cut the x-axis. X is 0, 1 minus x is 0, and x is 1. So 0 and 1 is where it cuts the x-axis, and it's a sad face, so B is the answer. The values of x for which that is equal to 64x are, brother man, all you can do is check. Just give this a check. You don't have to go and factorize this. Just give this a check. I'll look into see 3 plus 15 squared. If I take away 64x, I'm supposed to get 0. Take away 64 into 3. I get 0. So I know that 3 and 5 is not an answer. So given that 3 is not an answer, this is not an answer. Given that 5 is not an answer, this is not an answer. So the only answer left is D. And you can double check it if you want. 9 plus 15 squared. Take away 64 into 9. Supposed to get 0. We get 0. And 25 plus 15 squared. 1600, take away 64 multiplied by 25. We get 0. So we good to go. So you do 3 plus 12. Huh? And what by? Talk to me. Me and what you talk about? Well, the correct that we're moving along. The range of values for that is, let me go ahead and solve it now. X squared minus 7x plus 10 is equal to 0. We have a calculator. I am going to factorize and thing. Mode 2, a is 1, minus 7 and 10. Solutions are 5 and 2. X is 5, x is 2. Draw it on my number line. 2 and 5. I test in 0. When I test 0, I will get 10 is less than 0. If I test 0 in the equation, I test in 0 in here, I get 10 is less than 0. And making no sense. Where is 0? 0 is here. So here is not satisfied. Here is not satisfied. The middle is satisfied. The middle is, this is x is greater than 2. So 2 will be less than x, which is less than 5. 2 is less than x is less than 5, so B is the answer. The set of values for which that is greater than or equal to 0 is, let me go ahead and do it. You can just put in this one here, if we multiply by the square of the denominator, we get 2x plus 1 into x minus 1 is greater than or equal to 0. Again, we're going to solve. I get 2x plus 1 is equal to 0. I get x is minus a half. X minus 1 is equal to 0. I get x is equal to 1. Again, represented on my number line, we get minus a half. I get 1. I test in 0. When I test 0 in my original inequality, I will get 1 over minus 1. That is minus 1. And minus 1 is greater than or equal to 0. That's not making sense. So 0 not satisfying my inequality. 0 is here, so it doesn't satisfy. So my solutions are here and here. X is less than minus a half. Union, x is greater than 1. Less than or equal to. And x has to be strictly greater than 1. It can't be equal to 1. So it's less than or equal to a half and greater than 1. So you got to go there. If that is that, oh, this is another repeat question again. This repeat from last year, well, from the last class we did. We need to calculate the range. So we just substitute values, substitute lower value and the upper value. But we need to check. Luckily, we don't do this already, so we don't have to check. So when you just substitute the lower value, we get minus 2 over 9 into minus 3 cubed. Jump on the calculator. Minus 2 over 9 into minus 3 cubed. Good Lord. Minus 2 over 9 multiplied by minus 3 cubed. 6. So 6 will be my lower boundary, and negative 6 will be my upper boundary. D. The functions f and g are defined as follows. Tra-la-la-la, tra-la-la-la. The function f, this is another repeat question. No. Similar, but it's not a repeat, but it's similar. F of x is x plus 1 over x minus 1. And g of x is 2x plus 1. We want fg of x. Fg of x is f of 2x plus 1, which is 2x plus 1 over 2x plus 1 minus 1, 2x plus 2 over 2x, 2 into x plus 1 over 2x. Bam bam. X plus 1 over x, where x is not equal to 0. A. If the function m is such that x is mapped onto 5 plus 2x, then m of 4 minus 2a. So let me make life easy. This just telling me m of x is 5 minus 2x. I want to know what m of 4 minus 2a is. That is 5 minus 2 into 4 minus 2a. 5 minus 8 plus 4a minus 3 plus 4a, or 4a minus 3. 4a is 4 minus 2a. Yeah, 4 2s are 8. 5 minus 8 is minus 3. Oh, it's plus. Sorry. Plus 13. 13 plus 4. 13 minus 4a. Jesus Christ. 13 minus 4a is the answer. If f inverse x is x squared minus 1, then, okay, so f inverse x is equal to x squared minus 1, where x is greater than or equal to 0. Now, for multiple choice, you don't have to go and do the working to show what f of x is. If you want, you could go ahead and do so. But I'm going to show that little trick you can do here. In functions, we usually travel from domain to codomain using the function f of x. If I want to travel from codomain back to domain, I will use the function f inverse of x. So let me see. If f of 1 is equal to 16, then f inverse of 16 will be equal to 1. I can use any value of x in f inverse of x. So if I let x, I want to calculate f inverse of 2. That could be 2 squared minus 1, which is equal to 4 minus 1, which is 3. So f inverse of 2 is equal to 3, which means f of 3 is supposed to be equal to 2. So all I'm going to do, I'm going to check and see which one of these here, f of 3, is equal to 2. Which one will give me 2? And it looks like f of 3, b. B looking like the answer. Yeah. 3 minus 1 is 2. Nope. 1 minus, nope. Yep. B is the answer. Right. So if you want to use this concept, you could go ahead and use this concept. If you want to do your working to show back what f of x is, you have to let y equal this, interchange x and y. The same procedure as finding the inverse. Right. Number 12. This is a repeat question. There's a quarter. If you want, you could just jam this straight in a calculator. 2 to the power minus 1 is equal to that, divided by 8 to the power of a third. No shucks. Put your powers in brackets, please. 2 to the power minus 1 divided by 8 to the power of 1 over 3, 0.25, which is a quarter. Given that log of x to base p is 6 and log of y to base p is 4, the value of log of x over y to base p log of x over y to base p is log of x to base p minus log of y to base p. Simple laws of logs. 6 minus 4, we get 2. Given that 3 multiplied by 27 to the power 2x is 9 to the power x. 3 multiplied by 3 cubed to the 2x is 3 squared to the x. 3 to the power 1 plus 6x is 3 to the 2x. 1 plus 6x is equal to 2x. 6x minus 2x is 4x, is minus 1. X is minus a quarter. A. If you wanted, you could have just go and check each one of these answers in the question and see which one maintains equality. So if you're testing the first one, you go get through the first one time. The value of x for which that is 4 to the power x plus 1 is equal to 2. 2 to the power 2 to the power x plus 1 is 2 to the power 1. 2 to the 2x plus 2 is 1. 2x plus 2 is 1. 2x is equal to 2 minus 1, which is minus 1. 1 minus 2. And x will be negative a half. The value of x such that log of 5x plus 1 to base 2 minus log of 3x minus 5 to base 2 is equal to 2 is, right, no problem. We have, this is a quotient, so I'll have log of 2 5x plus 1 over 3x minus 5 is equal to 2. I'm going to use log the indice. If all are confused, just let me know. 2 squared is 5x plus 1 over 3x minus 5. 4 into 3x minus 5 is 5x plus 1. 12x minus 20 is 5x plus 1. 12 minus 5 is 7. 21. X is 3. B. Or look at see the working on everything properly. Let me know, please, in the chat. The series that converges to the limit. This is a, it's looking like a GP, where we test it and see. If I check in for a common ratio, it will be T2 divided by T1, which is 4 over 3 divided by negative 2, which is equal to 4 over 3 multiplied by negative a half. Bam bam, we get negative 2/3. And I check in my second term, which is 4 over 3 multiplied by negative 2/3. We get minus 8 over 9. So this is indeed a GP, and a good indication is GPs converge. So the convergence of a limit of a GP will be the, I'm going to do limits, it will be the sum to infinity, which is a over 1 minus r, given that the modulus of r is less than 1. A, which is minus 2, over 1 minus r, which is minus 2/3. Minus 2 over 1 plus 2/3. Jump on your calculator. Minus 2 divided by 1 plus 2 over 3. Negative 1 and 1/5, or negative 6 and 5, A. The sum of the first n terms of a series is given by that. The sum of the first 10 terms is, alright, so this will be the summation of r is equal to 1 to 10 of 5 minus 3r. It is AP. You can check your first term. When r is equal to 1, I get 5 minus 3, which is equal to 2. This is equal to T1. When r is equal to 2, I get 5 minus 3 into 2, which is 5 minus 6, which is minus 1. This is T2. T1 minus T2, well, T2 minus T1 will give me my common difference. Minus 1 minus 2, which is minus 3. So we want to find out my sum of the first 10 terms is equal to n over 2 into 2a plus n minus 1 d. This is equal to d. This is equal to a. If you want to go and check each term, you could go ahead and check each term and calculate it. So we get 10 over 2 into 2 into a. A is 2 plus n minus 1 multiplied by d. 5 into 4 plus 9 into minus 3. You could jump straight on a calculator and work this out here. 5 into 4 plus 9 into minus 3 minus 115 minus 115c. The sum of that is, this one is an easy one. When k is 1, I get 1 over 1, plus when k is 2, then when k is 3, so I have 1 plus a half plus a third, 156, or 11 over 6. We good so far? Tell me. Looking good so far. First four terms of a conversion GP are 500, 208. There's a repeat question. Sum to infinity of the GP is, so we have the sum to infinity is a over 1 minus r. Given that the modulus of r is less than 1, a 500 over 1 minus r is t2 over t1, which is 200 over 500, which is 2/5. 500 over 1 minus 2/5. 83 and a third. 2500 over 3. D. The line L passes through the point 6, 5 and is perpendicular to a line whose equation is 3x plus 4y minus 7 is equal to 0. The equation of the line L is, okay, so given that L is perpendicular to our line, we can use the properties of gradients. We can say that 3x plus 4y minus 7 is equal to 0. 4y will be minus 3x plus 7, and y is minus 3 over 4x plus 7 over 4. The gradient of this line is minus 3 over 4. The gradient of the line perpendicular to this will be 4 over 3, because when I multiply these two, I'm supposed to get minus 1. So I know that my gradient is 4 over 3 and the point is 6, 5, so I can say that y minus, this could be my x1 and my y1. Y minus y1 is m into x minus x1. Expand it out. Y minus, we could multiply by 3 one time. I get 3y minus 15 is equal to 4 into x minus 6. 3y minus 15 is 4x minus 24. What did they have first? Right, so the only one with 3y is these two here. So they had the 4x first. So 4x, I move the 3y minus 3y. I move the minus 15. I get minus 24 plus 15 minus 9. A. The line 7x minus 4y plus 25 and that intersect at the point P. The coordinates of P are, again, excuse me. Again, if you wanted to go ahead and solve them simultaneously, you could have done so. If you want to just substitute points inside of the two equations, you could do so as well. Given that these are two lines, we can go ahead and solve them simultaneously. So I have 7x minus 4y plus 25 is equal to 0. And I have 3x minus y minus 5 is equal to 0. I send the y across. 3x minus 5 is equal to y. I plug y into my first equation. 7x minus 4y plus 25 is equal to 0. I get 7x minus 12x plus 20 plus 25 is equal to 0. 7 minus 12 is minus 5. 20 and 25 is 45. Move it across, we get minus 45. I get x is equal to 9. So the only one of these values that have x is equal to 9 is C. So you get to go there. A circle has center 3 minus 2 and radius 4. The equation of the circle is, so they want it in this particular form. So I know that when I have an equation of a circle, x squared minus 2fx plus y squared minus 2gy plus c is equal to 0. Fg is the center. And the square root of f squared plus g squared minus c is the radius. So in this case here, we will have x squared. Now I'm doing this one a little different. Usually I will just put it in the form x minus a squared plus y minus b squared is equal to r squared, which indeed is a little easier, but I'm just doing this for a little variation. X squared minus 2fx. The center of this circle was 3 minus 2. So f is 3 plus y squared minus 2gy plus, we don't know what c is as yet, is equal to 0. So I just go in and check and see which one of the equations we can work with here. X squared minus 6x plus y squared plus 4y. So I have a x squared and a y squared and all. I'm looking for minus 6x plus 4y. C is my answer. I didn't have to go and work out the radius. If you wanted to use x minus a squared into y minus b squared, you could have done so. It could take a little longer, but I mean, you will still get the correct answer. Two vectors have another repeat. Two vectors are equal if they have the same magnitude in the same direction. The triangle AOB has vertices given by 0, 0, 3a, and 6, 3 respectively. Given that the angle AOB is pi on 2, then A is equal to, okay, very interesting question. So let me draw it and see what's going on here, right? There's a vertex. 6, 2 is a vertex. This is B, this is O, and A is minus 3 something. Minus 3 something. Could be positive, could be negative. Given that the angle AOB is pi on 2, which is 90 degrees, that is my 90-degree angle there. Interesting question. Let me go how to use like a dot product here. Alright? So I know that if I have AO dotted with OB, this is equal to the size of AO, the size of OB cosine theta. I have AO. AO is negative OA. So we know that our OA is minus 3A and OB is 6, 2. Yeah. The angle AOB is a right angle. Alright, let me use the dot product. After this, I will draw it and see if it have an easier way to do it. I'll show it have an easier way to do it. AO dotted with OB. AO is negative OA. Could be 3 minus A. And I'm dotting this with 6, 2. Multiply my i's and add it to the product of my j's. Cosine of pi on 2 is what? Yes, length and magnitude is the same thing. Cosine of 90 degrees is supposed to give me 0. Okay, good. So this whole thing here will be equal to 0. So 18 minus 2a is 0. So 2a is equal to 18, and I get a is equal to 9. Let me try it and see what we can do here, right? I want to visualize this one here. Very, very good to visualize these things. 0, 0 is 1 point. 0, 0. Then I have, I don't know what that is, but no, 6, 2 is the next point, right? 6, 2. And I know that how the next vertex of the triangle is minus 3 something. But I know that how the angle made between, I'll rename this as O I rename this one as 6, 2 is right. Good. So I know the angle made between AO and OB is 90 degrees, because they did say that our AOB is 90 degrees. So minus 3 something will give me this 90 degrees. If I draw it down here, nah, it will be a stretch to get 90 degrees down there. Can't get 90 degrees down there. So if we draw this, I'm drawing a line to A to OB. Based on the information given in the question, this fella here is a 90 degree. Now, a 90 degree over here can occur like this. It cannot occur nowhere else but like this. Alright, that's the only way it could occur. So what I'm going to do, I'm going to construct a perpendicular line to this over here. Perpendicular line to this over here. And I'm just going to check. Minus 3, going up, 9 will be the only point that will make this here a right angle triangle. I think the easier way is to actually do the dot product. Right? Do the dot product. Practice it. OA is that, OB is that, then AB is, right, this vector addition is AO plus OB. You had to put your arrows there if you was showing you working, but nobody has seen this working. AO is minus OA plus OB. I go still put it in, you don't have to if you're doing a shortcut. Minus 1725 plus minus 45. This could be 17 plus 4, which is 21. I don't even have to work on the next one. 21 is my top value. Which one of the following formula I use to calculate the area of a sector A, radius R, arc length L, and angle Q? Area of a sector is a half r squared theta. The angle is Q. So A is equal to r squared over 2. L squared over 2Q. I know 1 is part of it. Okay, let me draw this diagram and see, right? So we have an arc, R, Q, and L. We want to calculate the area of this sector. It could be area is 1/2 r squared theta, which is Q, which is r squared Q over 2. L squared over 2Q. I never see these other two formulas in my life. I never see this. What we could do, we can actually test it and see now. Right? We know it's a sector we're working at. let me actually give the radius a name. Let me say the radius is 4. Let me say this here is pi on 6. I can calculate L, my arc length. So L is equal to r theta, which is equal to 4 multiplied by pi over 6, which is 2 pi over 3. So this here is 2 pi over 3. So this diagram is accurate. Now given that the diagram is accurate, let's calculate the area of this sector. So the area is equal to 1/2 r squared theta, which is 1/2 4 squared by pi on 6, which is 1/2 of 16, which is 8. So we get 8 pi on 6, which is 4 pi over 3. I'm going to check the next formula here. L squared on 2q. L squared over 2q is equal to 2 pi over 3 all squared divided by 2 multiplied by pi on 6. We get 4 pi squared over 9 multiplied by, this goes here, we get 3 over pi. 3 goes into 9 3 times. Pi goes here 1 time. So I get 4 pi on 3. So this is actually another equation you can use to calculate the area of a sector. It's working. Let me try the last equation they gave us here. LR over 2. This is 2 pi over 3 multiplied by the radius all over 2. That could be 8 pi over 3 divided by 2, which is multiplied by 1/2, which is 4 pi on 3. So all 3 can be used to calculate the area of a sector. And we just now prove it here. Alright, so good food for thought. Very good food for thought. I am actually going to write this down. I didn't know that. Okay, right, don't know why, but right here. I really didn't know that. So we have area of a sector is equal to 1/2 r squared theta is equal to L squared over 2 theta, where L is the arc length, is equal to LR over 2, again, where L is the arc length. Cool. Good food for thought there, guys. Everybody good so far? Which of the following graphs represent sine of x? Sine of x, it makes one complete revolution in 2 pi radians, which is d. For that, the equation that has one real solution given by, so we have sine squared x is equal to 8 over 3. Square both sides, sine x is equal to the square root of 8 over 3. Oh, 8 cos x. Sorry, I didn't see the cos x. 8 cos x. 3 sine squared x is equal to 8 cos x. Good lord. 3 into 1 minus cos squared x is 8 cos x. Let me just read this, right? Has one real solution given by right, let me go ahead and solve it then. 3 take away 3 cos squared x is 8 cos x. Move everything across. I get 3 cos squared x plus 8 cos x minus 3 is equal to 0. Minus 9, I get, actually we could just solve this here, yes. Mode 2, 2, a is 3, b is 8, and c is minus 3. One solution is a third, and the next solution is minus 3. So we get cosine of x is equal to a third. B. Yeah, because if cosine of x is equal to minus 3, that has no solutions. Our next repeat question here. A half into 1 over root 2 into sine theta plus cosine alpha. Go back in the last video if you want. Check back and see what's the answer for that. Tan of 2x plus pi on 4 is equal to, right, so we have a double angle for tan. So we know that our tan of a plus b is equal to, I can't remember, we can't check it out. We didn't get a formula sheet here. Right, we need to remember this one here, right? Right, I can't remember it, so tan is something that does hardly come. And so tan of a plus b. Tan a plus tan b over 1 minus tan a tan b. Tan a plus tan b over 1 minus tan a tan b. So we want tan of 2x plus pi on 4 tan 2x plus tan pi on 4 over 1 minus tan 2x tan pi on 4. Tan of pi on 4 is what? Set up that, no. Right, we are in radians. Tan of pi on 4 is 1. So we get tan 2x plus 1 over 1 minus tan 2x. Tan 2x c. If sine of x plus 20 is equal to cosine of x, then the value of x is. This was one of them kind of another one of the confusing tricks questions. So let me see how we can, let me dissect this up and see what we can do now. Sine of x plus 20 is equal to cosine x. Now, this is actually of the form of a double angle on both sides. So if I expand the left hand side using the not double angle, using the compound angle formula, I'll get sine x cosine 20 plus cosine x sine 20. I actually have cosine x and a sine on this side here. Alright? Just substitute. Yeah, we could just substitute for that one, right? We could substitute for number 33. Alright, but this is another way to do it. We can equate corresponding coefficients. So this is 1 cosine x. So this one I'm making no sense. Sine 20 is not 1. Sine x, I don't have a sine x, alright, so substitution for the win. So let me check and see. Is either have sine of 35 plus 20 minus cosine of 35 is equal to 0. Sine 45 plus 20 minus cosine of 45 is equal to 0. Sine 55 plus 20 minus cosine 55 is equal to 0. And lastly, sine of 70 plus 20 minus cosine of 70 is equal to 0. As you can see, sine of 55, take away cosine of 35. Now, sine of 465, take away cosine of 45. Nah. Sine of 567, 75, take away cosine of 55. Nah. And sine of 90, take away cosine of 70. Add correctant. 55, 35. Yeah, I added 5, 6, 7, 4, 5, 6. Let me check over C. 75. Oh shucks, I have it in radians. Sorry. My calculator was in radian, that's why. Sine of 55, take away cosine of 35 is the answer. Let me just check the rest. Sine of 65, take away cosine of 45. So is the answer. So that means that sine of 55 and then cosine of 35. I'm trying to figure out a way to prove it. I want to figure out a way to prove this. The only way I did this is by substituting in all the other past papers that I did. So just substitute, yes. 1 mark. Take a 3 minutes and do your substitutions. For theta is equal to that, tan theta is 4 and 3. The exact value of tan 2 theta is another double angle. Tan 2 theta is 2 tan theta over 1 minus tan squared theta. I think. Let me double check that again. Right, tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So I was correct. So this is 2 tan theta is 4 over 3 over 1 minus tan squared theta. You go u, you get 2 2's on top, divided by 9 over 16 over 9. 1 take away 16 over 9 minus 7 over 9, and 2 over 3 divided by that minus 6 over 7. Why cancel the 4 boy? That is 8 over 3. This is 8 over 3. 1 take away 16 over 9 and 8 over 3 divided by the answer minus 24 and 7. The differential of that is, I just put in y is equal to 7x squared plus 4 to the power half. Shortcut to the chain rule, we get 1 half into 7x squared plus 4 to the minus a half multiplied by 14x. So half of 14x is 7x over the square root of 7x squared plus 4. B. At the point that on the curve y is equal to f of x. dy dx is 0. And d2y over dx squared is equal to minus 5. Alright, so given that dy dx is 0, I know it's some sort of turning point. Since the second derivative is negative, that means it's a maximum point. Easy pickings. The gradient at x is equal to pi on 6 on the curve, that is, get the gradient function. Is equal to negative sine x. When x is pi on 6, we get negative sine pi on 6. Pi on 6 is 30 degrees. So sine of 30 degrees is a half, so negative a half is the answer. I just plug in 30 degrees because my calculator was in degrees already. Given that y is equal to cos 2x, dy dx is negative 2 sine 2x. The gradient function dy dx of the curve that is, alright, so we had to differentiate this. When I differentiate sine, it turns into cosine. The angle remains the same, but I need to multiply by the differential of the angle. When I differentiate the angle, I get 4x, so the 4x goes in front here. 4x cos 2x squared plus 1. The region bounded by the curve, the x-axis, the lines x is 0 and x is 1, is rotated about the x-axis. So I know one time rotation about the x-axis, pi y squared dx. Now I'm going to plug in my limits, 0 and 1. Y is equal to x squared. So y squared will be x squared squared, which is x to the power 4. So pi x to the power 4. So D is the answer. Gotta bring the pi outside. The integral of that, again, we could use a shortcut to the chain rule. Integrate normally, we get 2x minus 5 to the power 4 over 4. And the 4 had to be multiplied by the differential of the brackets, which is 2. So we get 8 on the denominator. Plus c. So it's 2x minus 5 to the power 4 all over 8 plus the constant c. Integral of sine x minus cos x. For like this here, if y is cos x, dy is negative sine x. So when I integrate sine, I get negative cosine. That's all I need to know. Integral of sine x minus cosine x dx. When I integrate sine, I get negative cosine. When I integrate cosine, I get regular sine. Plus c. So now minus cos minus sine, minus cos minus sine plus c. If that is equal to 72, a is equal to 0, then a is equal to, alright, let me integrate this here, 6 plus 3x. When I integrate that, I get 6x plus 3x squared over 2. Evaluated between a and 2. So substituting a, 6a plus 3a squared over 2. Take away 6 into 2 plus 3 into 2 squared over 2. And I say that all this is equal to 72. So I get 6a plus 3a squared over 2. Take away 12 plus 6. 6a squared plus 6a, sorry, plus 3a squared over 2. I'm moving that 18 on the next side. It becomes plus 18. It becomes 72 plus 18 is 90. Brother man, I'm just going to substitute and check. I ain't going to bother to solve. Because when I solve this, I go get a quadratic. Substitute one time. I check in 6. 6 into 6 plus 3 into 6 squared over 2. x is that and a is less than b, this is a nice question, right? For this question, I want to take my time and show you what to do here, because a lot of teachers doesn't teach this properly. Remember when we're integrating underneath a curve, and we have a limit on the curve, there are certain parts we are integrating underneath. So looking at this, a is less than c is less than b. If a is less than c, then a comes here and c comes here. And I say c is less than b, so b comes here. If I am integrating underneath this fella here, between a and b, that is the exact same thing as integrating between a and c added to the integral between c and b. So if I have the integral between a and b, f of x, that means I'm integrating underneath between the limits a and b. This is equal to the integral between a and c, where c is my upper limit, so I get c and a f of x, plus the integral between c and b, where b is my upper limit. Now, to have another law where we can change the limits by inputting a minus sign inside of there. I don't know if that will be applicable to this, but let me check and see. I'm looking for the integral between c and a and the integral between b and c. So c is the answer. Now I just want to show a little variation for this one here. This is also equal. If I multiply this by a minus sign, I'm allowed to do that as long as I flip the limits. So I can say this is minus the integral, but I have to flip the limits, a and c, f of x, plus b and c, f of x. If I wanted to multiply the second integral by a minus sign, I must also flip the limits on that. Alright, so it's not that I multiply by a negative sign or a negative number, negative 1. And I change the limits on both of the integrals. I'm just doing it for one of them at a time. Lastly, the region enclosed by the x-axis, the curve, okay, so actually what the area this time here, right? So don't do like me like last time and they just wanted the equation. They actually what the area, the way I calculated. So they want the area between 3 and 2 of x squared plus 2x minus 1 dx. That could be x cubed on 3 plus 2x squared over 2 minus x. Evaluated between 3 and 2. I'll substitute in 3 first. I get 3 cubed over 3 plus 3 squared, take away 3. Take away, and then I substitute in 2. I get 2 cubed over 3 plus 2 squared minus 2. Jump on my calculator. This is, so I could work this out right here. 3 3s are 9, 3s are 27. 27 divided by 3 is 9. 9 plus 9 minus 3. Take away 2 2s are 4, 2s are 8. 8 over 3 plus 4 minus 2. 9 and 9 is 18. 18 minus 3 is 15. Take away. Now I can work it out here. 15 take away, open bracket, 8 over 3 plus 4 minus 2, close bracket, 10 and a third, which is the same thing as 31 over 3. B is the answer. Questions? Are listening? Doing 2018 one time, right? Or if you have any questions. You listening? Will I read any comments? The chat. Any questions on the last paper? If you have questions, I could go back to it on any one of them. I did. We'll do it over tomorrow. Right, we will do it over tomorrow, don't worry. Given that specimen paper 2 came exactly like our paper 2 this year, I'm going to guess that specimen paper 1 will be similar to our paper 1 this year as well. Right, so we will be doing it over tomorrow. Here's Shane. We've seen. Again, all those who want to do pure, I'll go number again. If you are interested in doing pure lesson starting next month. 793 4754. Right, so we will be finished with at least half of module 1 before school start, so they will get a good jump start on the school term. Yeah, about half of module 1. This is for pure, right? Right, follow one pure number ID. Nobody have any questions? You actually finished this paper in an hour because you spent 20 minutes talking and waiting for people to dive in. Not bad. Alright, so load up this one. Right, we will start this one in 2 minutes. I'm listening for any questions, right? Any questions, feel free to ask. Right, give me a minute. Right, so I see a man say do Nova number 39. Right, let me do it. Number 39, you say, Gerald. Numero 39. Okay, cool. I'll go a little more in depth in it this time, right? Whenever we are differentiating a trigonometric function, if y is equal to ax, no, not ax, sorry. Y is equal to a sine bx plus c. Then dy dx is equal to the differential of the angle multiplied by a, the sign changes the cos, a cosine bx plus c. If I have y is equal to a cosine bx plus c, then the differential will be the differential of the brackets, or the angle, multiplied by the cosine changes to negative sign, minus a sine bx plus c. So if we perform my example here, if y is equal to, let me say, 3 sine 2x squared plus 3x minus 6, then dy dx will be equal to the differential of the brackets, which is 4x plus 3 multiplied by 3, and the sign changes to cosine. The angle remains the same. Remember, the angle is sacred, you don't touch it when we're doing any algebraic expansions. If you want to expand this, this becomes 12x plus 9 into cosine of 2x squared plus 3x minus 6. This happens every single time. I'll show you one, I'll show you all. If y is equal to, just put cosine of 4x minus 1, then dy dx will be the differential of the bracket, which is 4. The cosine changes to negative sign, so I can put the negative on the outside. Negative sine 4x minus 1. Tell my Gerald. Look good? Sound good? How movie? I'm playing this a little bit here. Good day? Cool. Right, now we dive into 2018 now. Repeat. Right, although repeat, they go mix up the order of the answers, so we go have to go ahead and factorize it again. I'm going to do this paper in blue. AB plus minus 3B minus AC plus 3C. B into A minus 3. Take away C into A minus 3. A minus 3 into B minus C. The linear factor of that is, just plug in values here. Let me see if I get a better copy of this. Give me a second. I don't like how this copy looking. If anybody has anybody have the paper one, let me know. I think this is a good website here to get that, you know. I think so. Looking through. Hey, let me see if this looking good here. This paper 2. For paper 1. Let me see how this looking here. There's maths. Add maths. Why put maths? Did I download this? I have an next specimen paper here we could do it now. Alright. Here what? Let me do the specimen paper instead, right? Alright, let me try a thing with this one here. If you go back to the same link that pinned in the comments, you'll see it has a folder, a file called document 1. That will be the paper we're going to do now. So go ahead and get. That's what we're gonna do. This looks like a good paper to do. Right, so one already. Right, it's pinned in the comments. So yeah, it's uploaded. So document 1, that's the paper we're going to do now. Right, I mean, they will still be able to see it over here, so I guess we can get started. Given that f of x is that and x minus 2 is a factor of f of x, then k is equal to, right, so we have f of x over x minus 2. This will give me f of 2. And they say x minus is a factor, so f of 2 is equal to 0. 2 cubed, 2 squared is equal to 0. 8 plus 2 to the 4 to the 8 minus 5 to the 10 plus k is equal to 0. 16 take away 10 is 6, move it across, minus 6. Alright, so this here becomes AB, I'll do the expansion next stage here now. AB plus AC minus AB minus BC. AB minus AB, so I get C into A minus B. The value of this is, I did this one just now. This is a nice question again. This is a AP, so let me go and expand on the AP. So this here, T1 is equal to 3 into 1 minus 1. 3 minus 1 is 2. T2 is 3 into 2 minus 1. 3 2s are 6. 6 minus 1 is 5. So my common difference will be 3. So the sum of the first 20 terms, actually we can calculate the last term. T20 is equal to 3 into 20 minus 1. 60 minus 1 is 59. Is n over 2 as 20 could be 20 over 2 into a plus L 10 into 61, which is 610. A teacher illustrates APs by cutting a length of a string into 10 pieces so that the length of the pieces are in arithmetic progression and the entire length of the string is used up exactly. If the first piece measures 30 centimeters, so T1 is 30, and the fourth piece measures 24 centimeters, then the total length of the string is, alright, so they cut up into 10 pieces, right? T sub n is equal to a plus n minus 1 d. So T1 will be a plus 1 minus 1 by d. So T1 is equal to a. So a is 30. T4 is equal to a plus 4 minus 1 by d. A is 30, T4 is 24, plus 3d. I can divide everything by 3, so I get 8 is equal to 10 plus d, and move the 10 across, so I get minus 2 is equal to d. So my common difference is negative 2. Just double check that. T4 is 24, right? Good. We want to figure out the sum of the first 10 pieces. The sum of the first 10 pieces could be 10 over 2 into 2a plus n 10 minus 1 by minus 2. 5 into 60 plus 9 by minus 2 is 60 minus 18. 60 minus 18, 42 by 5, 210 centimeters. That was a nice question. The first term of a GP is 16. So T1 is 16, which is equal to A. And the fifth term is 81. Given that the common ratio is positive, the value of the fourth term is, the trick in GPs is to divide them. T5 over T1 is equal to AR to the 4 over A, which is equal to R to the 4. So T5 over T1 will give me R4. T5 over T1 is 81 over 16 is R to the 4. If we fourth root both sides, I'll get the fourth root of 81 over 16 is equal to R. The fourth root of 81 is 3. The fourth root of 16 is 2. 3 over 2 is equal to R. Therefore, the fourth term, T4 is equal to A R to the power n minus 1 cubed 16 into 3 over 2 cubed 16 into 3 over 2 to the power 3. 54. C. Everybody good so far, right? Let me know in the chat if everybody comfortable so far. The first four terms of a convergent GP is that the sum to infinity, right? So sum to infinity is equal to a over 1 minus r if the modulus of r is less than 1. 81 over 1 minus 3 over 9 is 1/3. So 81 divided by 2/3 is 81 multiplied by 3 over 2. That could be that could be the only answer. 81 by 3 divided by 2. That is that, then that, tra-la-la-la-la. Alright. 2 multiplied by 2 squared to the power x plus 1 is equal to 2 to the power 4 to the power 2x. I could expand this one time. 2 to the power 1 plus 2x plus 2 is 2 to the power 8x. 1 plus 2x plus 2 is equal to 8x. Move the 2 across. I get 6x. 3 is equal to 6x. X is 3 over 6, which is a half. This is equal to, so the nth root of 2 multiplied by 4 to the m, that will be 2 by 2 to the 2m to the power 1 over n, 2 to the power 1 plus 2m to the 1 over n, 2 to the 1 plus 2m over n, or 2m plus 1 over n, d. Given log of x to base 2 plus log of 6x plus 1 to base 2 is equal to 1. The value of x is, right, so we add in, so we could multiply these two here. So this becomes log of x into 6x plus 1 to base 2, which is log of 2 to base 2, because log of a number to the same base is 1. So I get 6x squared plus x is equal to 2. 6x squared plus x minus 2 is equal to 0. Go and calculate and solve this. Mode 2, 2, 6, 1, minus 2, a half, and just a half alone. Yeah, because we cannot have the log of a negative number, so the answer is positive a half. The value of that is, everything is 4 to base 4, so we can use the laws and combine everything. This is log of 8 divided by 2 multiplied by 1 on 16. 8 divided by 2 is 4. 4 multiplied by 1 over 16 is a quarter. So I have log of 4 a quarter. This is log of 4 to the minus 1 to the base 4. Move the minus 1 in front. This becomes 1 minus 1 log 4 to 4, which is minus 1. The expression when simplified is equal to, I'm not going to bother to rationalize. I just going to minus and see which one I get 0 for. So 1 plus root 3, 1 plus root 3 divided by root 3 take away 1. I got that there. I'm storing that in A. Right, so let me just recall what A is. 3.7. I'm gonna check D. Root 3 plus 2, 3.7. Root 3 plus 2, 3.7. If I take away A, suppose I get 0. D is the answer. The only reason I decided to check D is because D is a little easier to input on my calculator. I know A and B cannot be the answers, and I'm gonna try to put in a fraction with a surd in it on my calculator to minus. Might as well just plug in D and check it. By completing the square, f of x can be expressed as, alright, no problem. What I'm gonna do, I just gonna I'm going to complete the square. So I know that how A is minus 2, B is minus 8, and C is minus 5. So I know A is A, which is equal to minus 2. I know H is equal to B over 2A, which is minus 8 over 2 by minus 2, minus 8 over minus 4, which is positive 2. And K is equal to C minus AH squared, which is minus 5 minus AH squared. Minus 5 take away, minus 2 to the 4, by that is minus 8, minus 5 plus 8 is 3. So it could be A into X plus H squared plus K. So we could put the K in front, 3 minus 2, nope, 3 minus 2 into X plus 2 all squared, C. The roots of the equation are, I don't even have to check the discriminant, mod 2, 2, I get 2 minus 1 and 1 imaginary. They are not real, 0.25 and 0.25, they are not real and equal, C. The reason I know they are not real, when you're checking these things on a calculator, equal, 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 see this xy on top here, that tells me that's imaginary roots. If I input another quadratic, let me say 2, 3, and 1, I wouldn't have the xy up in the corner here, which means these roots are real and distinct. But if you want, you could go ahead and check your discriminant. Between this, the minimum value of that and the value for which that is a maximum, or the maximum value, right? Between this interval, the maximum value of this and the value of x for which this is a maximum are respectively, we could use calculus and do this. All right, so they didn't really anticipate us to use calculus here. So dy dx is equal to minus 2 into x plus 1 multiplied by 1, which is minus 2x minus 2. Put this equal to 0, and I will get my maximum my value of x for which the function is a maximum. Minus 2x is equal to 2, and x is equal to minus 1. When x is minus 1, y is equal to 4 minus 1 plus 1 squared. This is 0, y is equal to 4, so minus 1 and 4, minus 1 and 4 is C. Easy peasy lemon squeezy. F of x is equal to x into that, given that f is 1 to 1. For x is greater than k, the value of k is, given that f of x is 1 to 1, x will be 1 to 1, x squared plus 5. Greater than or equal to. Oh, okay, so this could be another minimum point. This function will be 1 to 1 everywhere except at the minimum point. So at the minimum point, x will be equal to something. So let me calculate the minimum point of this function here. So f of x is equal to x squared plus 5x plus 6. F dash x is 2x plus 5. Put it equal to 0. And x is equal to minus 5 over 2. So when x is minus 5 over 2, it's not 1 to 1. To illustrate this, I would like to illustrate this further to understand what's going on here. X into x plus 5, x into x plus 5 plus 6. So this function is 1 to 1. No, this is not 1 to 1. Sorry. I calculated for its many to 1. They say given that f of x is 1 to 1, but the thing is, this is a quadratic and it only have one spot on this graph where x is 1 to 1. Okay. Yes, correct. So we're good. F of x is 1 to 1 only at this point here. Alright? All I see my mouse? Just now, huh? I was supposed to see my mouse, man. Yeah, capturing cursor. Right, there's that there. Right. Over here, f of x is 1 to 1. That's the only spot where f of x is 1 to 1. Everywhere else, f of x will be many to 1. Right, I'm not gonna dive into too much. Unless I want me to. Right, for paper 1, I don't want to dive into too much. It will take a while because you have to really understand what 1 to 1 means graphically. For the 1 to, let me know. A function f is defined by that. F inverse of minus 4 is equal to go and find f of x, f of minus. Let y equal x plus 3 over x minus 1. Interchange x and y. X is y plus 3 over y minus 1. Solve for y. X into y minus 1 is y plus 3. Xy minus x is y plus 3. Xy minus y is 3 plus x. Y into x minus 1 is 3 plus x. Y is 3 plus x over x minus 1. When x is minus 4, 3 plus minus 4 over minus 4 minus 1, minus 1 over minus 5, which is 1 over 5. And so must be 1 over 5. A function g is defined by that, expressed in the form ag. Expressed in the form of a, expressed in terms of a, g of 3a plus 1 is. So if g of x is 3x minus 1, g of 3a minus 1 is 3 into 3a minus 1 minus 1. 9a minus 3 minus 1, 9a minus 4. The functions f and g are defined by f of x. F is such that x is mapped onto 3x minus 2. The composite function fg is defined by, okay, so we have f of x is 3x minus 2 and g of x is 12 over x minus 4. Fg of x is f of 12 over x minus 4. So what I want to do, I want to actually change g of x to a single fraction. 12 minus 4x all over x. 12 minus 4x all over x. X all over x minus 2, which is equal to 36 take away 12x all over x minus 2, which, right, 3x minus 2, good. Right, we could break it up now. 36 over x minus 12x over x minus 2. Bam bam. 36 over x minus 12 minus 12 minus 2 is minus 14. B. Yeah, nice paper. We could do up to 20 here, guys, and we're looking off at 5. And tomorrow we could just pick up where we left off, right? A little tired. The range of values for which 2x is less than that is, right? So again, we have 2x squared minus 5x minus 3 is equal. I put it equal to 0. I'm going to solve this bad boy here. 2 minus 5 minus 3. 3 and negative a half. Minus a half and 3. I'm testing 0. When I test 0 over here, I get 0 will be less than 3. Making sense? 0 is in section 2. So in section 2 it could be minus a half. X is greater than a half. So a half minus a half is less than x is less than 3. Yeah. The values of x which satisfy the inequality 2x minus 3. If I multiply by the square the denominator, I'll get this. I'll put it equal to 0. 2x minus 3 is equal to 0. X is equal to 3 over 2. And I get x is equal to minus 1. Again, minus 1, 3 over 2. I test in 0 over here. When I test 0, I get minus 3 over 1, which is it making sense. 0 is here. So here not making sense. So here and here making sense. X is less than minus 1. X is greater than 3 over 2. Alright. I could go ahead and finish all this paper if all I want. I will just do finish the solutions to the rest tomorrow. What I'll also do for tomorrow, we're going to do specimen paper from the syllabus, the new syllabus. We'll do that specimen paper, finish off this. When this video goes public on YouTube, leave a comment if you want me to complete any topics, so I'll know how to prep myself for tomorrow. Any questions before we leave? Alright, well, I see nobody asking any questions. So given that nobody asking any questions, I'll see everybody tomorrow. Again, leave a comment if we can start earlier. If we could have a 6-hour stream, let me know. And leave a comment under the video tomorrow. Well, when it goes public, leave a comment underneath it. Let me know the time we can potentially start. And I'll see everybody tomorrow. Peace.